As we saw, the dedicated threads were useful in the sense that they allowed us to do the work in the background, but they weren't perfect, right? I mean, one thing is just that the operating system itself just kind of to start up a thread, to run a fairly short-lived task and tear it down. If we're doing that with any frequency, it's pretty resource intensive. The other thing was just a lot of boilerplate code, right? In order to update the user interface, we were doing a lot of extra stuff, right? We were declaring extra class level variables to hold information temporarily, doing a lot of embedded class implementations to try to run things where we needed them to run. We'd like to do something a little better than that. And that's where asynchronous tasks come in. Asynchronous tasks provide a standard solution to the kind of problem we were dealing with, running something in the background that needs to periodically interact with the user interface. Asynchronous tasks are implemented using a class called async task. And what happens is that this provides kind of a standard set of behaviors for us. And its real purpose in life is maintaining user interface responsiveness. So what ends up happening is that we're going to derive a new class from an async task class and then implement specific steps in the processing for that. And so it divides the work into distinct phases. And these basically are just overridable methods in the class. Now, you don't have to implement every phase. There's a onPreExecute phase, which is a function that will run on the UI thread that lets you maybe gather up any work you need before you do a task. Then there's a doBackground method that runs on the background thread. So that's actually running back away from the user interface thread, allowing us to do the work we need to do. doBackground is the only one you actually have to implement. But since we probably want to give the user interface common updates, there's a function you can call publishProgress, which then in turn calls a method called onProgressUpdate that allows you from your background thread to pass information that will run on the foreground thread to update the user interface. Then after work is done, there's an onPostExecute method that will run on the user interface thread. So basically, it's giving us this ability to do a background task in this doBackground method, and then common, easy ways to do specific operations on the user interface thread. And the thing about it is that it provides guaranteed sequencing, and it guarantees that things happen in a certain order. So that it guarantees that if you're doing anything in onPreExecute, which is things you want to do to gather from the user interface, that function will complete before the system fires up doBackground. And then if you're using onPostExecute to do something after the work is done, the class guarantees that doBackground finishes before onPostExecute is started. So it just gives us some guaranteed sequencing to deal with this stuff. And so it gives us greater efficiency than dedicated threads as well, because the system actually uses an internal thread pool. So if you're actually firing off a bunch of these, we get the efficiency of reusing the same threads over and over again. The thing to note, though, is that in terms of how long of an operation you can perform, asynchronous tasks are just like threads in the sense that something more than a few seconds long is not guaranteed to finish. The OS may kill it. So again, we have to look at the services that we're going to talk about a little later to look for those longer running scenarios. Now, async task is a parameterized class. So you actually have to give it some type information when you create it. And the type information you give it has to do with what kind of information you're passing around through the various steps. So basically, the three type parameters are, when you go ahead and want to run an async task, you call it an execute method. That first parameter type is what kind of parameters you'll be passing to the execute method. Whatever parameters you pass to the execute method, the class will internally pass to your doBackground method. Those parameters are actually a variable length parameter list, so they actually get passed to your system as an array. Then the second type parameter you give it is that when you want to update the user interface, so from your doBackground, you're going to actually call publishProgress periodically. That's the information you want to pass to the user interface to actually update the UI. And then when your doBackground is finished, it returns some kind of value, and that's supposed to indicate how the processing went. And the result of that is actually passed to the onPostExecute. So what we're really doing here is just kind of describing a process of working through a set of steps and passing information between those steps. Okay, so let's take a look at an example of how we can implement that inside of the problem we've been working on.